All right, so then for the next few weeks, what we're going to be talking about are sedimentary rocks and environments. And environments is going to be is really going to be what we talk about mostly. The environments in which sediments are generated, transported, and deposited. So what we're going to do with this PowerPoint is we're going to start out with just a brief introduction to sedimentary rocks and environments in general, and then we'll start talking specifically about the environments associated with rivers. So we're kind of mixing things up here in terms of the textbook, but the idea is if we follow the rock cycle, the part of it that is most visible to us is the part that's at the surface. So it includes the weathering and erosion of earth materials, the transportation of those materials to a new location, and then their ultimate deposition, burial, and conversion into sedimentary rocks. So we're really going to focus on this stuff that we can see at the surface. And so these processes are also referred to as geomorphological processes. And geo is earth, morph is shape. So we're really looking at the processes that shape the surface of the earth at the surface. When we get into the second half of the semester, we'll start talking about internal processes, things that might lift rocks up and create mountain chains and stuff. But these are processes that are active at the surface. We can go out and look at them, see what's going on. And the reason I put these first is because one of the earliest things geologists did was recognize the connection between these surface processes and the sedimentary rocks that they found. So what we'll start out with is just briefly, where does sediment come from? Well, sediment comes from the weathering of rock. And weathering simply means the physical and chemical breakdown of rocks. So those are the two types of weathering that we have. Weathering ultimately produces smaller and rounder pieces of rock. It produces a set of minerals that we call clay minerals, and it produces dissolved ions in solution. So the two general categories that we see here, physical weathering physically tears the rock apart. That's what gets us smaller pieces, more pieces, rounder pieces. It's going to knock the corner off a jagged piece. And over time and distance, it's going to make the sediments that we find smaller. It's basically going to beat them up and tear them down. Physical weathering can include anything from roots getting into a crack in the rock and kind of breaking it open. Water can get in there, and when it freezes, that can open up a fracture. What we'll see as we go through these different surface processes are physical types of weathering. For example, wind, water, and ice can all take small pieces of rock and rub them against big pieces of rock and cause some more physical weathering. Chemical weathering usually involves water or oxygen or both. It can involve some other things as well, but our two big agents very active at the Earth's surface are going to be oxygen and water. Water can attack minerals in such a way that it turns them into different minerals. That's where the clay minerals come from. Water can also dissolve certain ions, and then those materials end up in solution. Oxygen in the air can cause oxidation. Oxidation gives us rust. It gives us tarnished copper and silver and aluminum. So oxygen is a very active element and tends to break things apart as well. There are some other types of weathering that we might hit on as we go through the different materials, but it's something to keep in mind. So as we go through some of these processes, you might think about how that breaks apart rock, how it weathers rock. So that's the weathering of the rock part. Once the material is weathered, it can get eroded and transported to a new location. And after that occurs, it can get buried and turned into stone. And we're going to revisit this in a few weeks. We'll focus on the formation of sedimentary rocks. But I want you to keep this kind of in the back of your mind, because when we find a sedimentary rock, very often it makes us think, what was the environment present when this sediment was originally deposited? And so that's what we're going to spend a fair amount of time talking about. And so that's where this slide comes from. It shows you a couple of diagrams from the book that are meant to highlight the variety of environments of deposition that we might encounter, and the processes in general that we're going to be covering over the next few weeks. Prominent on this top diagram, you can see rivers. So we're going to see what happens along and at the ends of rivers. There are some glaciers here. There is a desert presumably over here and right here. You can see wind activity. There are swamps here and here. There are lakes. Of course, in this bottom diagram, we have the ocean. You can see coral reefs, a river delta, some sand dunes, a beach. So lots and lots of possibilities for environments where sediments can be deposited, and then those deposits later preserved through the process of what we call lithification, or turning into stone. As we go through these different environments of deposition, I want you to think about the characteristics of sediment in each of those environments. Every environment of deposition has its own set of conditions, and therefore results in different collections of sediment and different types of sediment being deposited. So you can see some of the clues to look for are how well sorted are the sediments. These top two slides are meant to show you very poorly sorted on the left and very well sorted on the right. You can look at how round the sediments are. So are they jagged like you see on the left, and are they rounded off like you see on the right, in the second row of pictures? We can look at what we call sedimentary structures. When wind or water moves the sediment, very often the current will produce what we call ripple marks. And you can see in the upper right-hand corner, there are some ripple marks there. On the third row on the left-hand side, you can see ripple marks. On the right-hand side, next to that, you can see mud cracks. And then underneath that, you can see something that we call graded bedding. You'll notice there are kind of large pieces at the bottom, and the size gets smaller and smaller as you move up toward the top. And then on the lower right-hand corner, you can see something that we call cross beds. Sediments are deposited in layers. We will talk about that more again when we get kind of to the end of this unit on sediments and how they move around. But a couple things about sediments. Number one, these layers of sediments are deposited generally in flat horizontal layers. You'll see within the layers in the lower right-hand side, there are additional layers that kind of go across the primary layering. And that is due to the way the sediments were deposited. There are a number of things that can cause that. Wind is a real prominent example, but there are other things as well that can cause cross beds. So anyway, that kind of gives you a general idea of where we're headed. And so what you'll see on the next set of slides is we're going to start talking about these different environments of deposition. And the first of these environments that we'll talk about will be rivers. And so I'm going to pause this narration right here, so you've got this kind of general introduction, and then the next set of slides will get into what's happening in and with rivers.